Let's look at adding and subtracting rational expressions. For example, let's add these two rational expressions together. Just like when we add fractions, we need to make sure that the denominators are equal before we add the numerators. And here we see that they're different, which means we need to find the least common denominator. And in this case, it's the product x minus 1 times x minus 2. So this is equal to 5 divided by x minus 1. And now we need to multiply both the numerator and denominator by what's missing from the LCD, which in this case is x minus 2. And in the second fraction, what's missing is this x minus 1. All right, and by commutativity, this x minus 1 times x minus 2 and x minus 2 times x minus 1 are equal, which means now we can add the numerators. In other words, this is equal to 5 times x minus 2 plus 4 times x minus 1, all divided by x minus 1 times x minus 2. And now we can distribute both the 5 and the 4, which gives us 5 times x minus 10 plus 4 times x minus 4, all divided by x minus 1 times x minus 2. And finally, combining like terms in the numerator, we get our answer of 9x minus 14, all divided by x minus 1 times x minus 2. All right, let's see another one. Again, we notice that these denominators are all different, which means we need to find the LCD in order to combine the numerators. But what we'll need to do first is factor the denominators to see what that LCD is. So this first denominator will factor into y plus 3 times y minus 1. And then the second one factors into y minus 1 times y minus 2. And finally, the last one factors into y plus 3 times y minus 2. All right, so what is the LCD here? We see that this y plus 3 is a common factor to two different denominators, which means we only need to include it once in the LCD. Same with this y minus 1, as well as the y minus 2. Which means that the LCD is the product of those three binomials. So y plus 3 times y minus 1 times y minus 2. And this will be equal to y divided by y plus 3 times y minus 1. And again, we're going to build up these rational expressions by multiplying both the numerator and denominator by what's missing from the LCD. In this first case, it's the y minus 2. And in the second case, we're missing the y plus 3. And in the last case, we're missing the y minus 1. Again, by commutativity, these denominators are all equal, which means we can combine these into one fraction now. In other words, this is equal to y times y minus 2 minus 1 times y plus 3 plus 5 times y minus 1, all divided by y plus 3 times y minus 1 times y minus 2. And now distributing in the numerator, we get y squared minus 2y minus y minus 3 plus 5y minus 5 divided by y plus 3 times y minus 1 times y minus 2. And now combining like terms in the numerator, we have y squared, and then we have minus 2y minus y, which is negative 3y, plus 5y, which is positive 2y, and then negative 3 minus 5 is negative 8, divided by this y plus 3 times y minus 1 times y minus 2. And now the numerator factors. It factors into y plus 4 times y minus 2, and then we still have this y plus 3 times y minus 1 times y minus 2 in the denominator. And now look, these y minus 2's can cancel, and we're assuming here, of course, that y cannot equal 2, which leaves us with our answer of y plus 4 divided by y plus 3 times y minus 1. And this is how we add and subtract rational expressions. Thank you, and we'll see you next time.